Hi class. I hope that you have a wonderful Thanksgiving break so far. One of you actually sent me an email today to ask for my elaboration on the question 9.14, and this video, short video clip, that what I'm gonna do is to talk a little bit about this question with respect to what they are asking for. If you read this question carefully, 9.14, it says find the total average power supply and the average power absorbed by each element in the network in figures 9.14. And from this figure, as you can tell, you have so many elements here. You have element 2 ohms, and then minus J2 ohms and 2 ohms and J2 ohms. And what we are actually interested is that the real number of that, which is resistor. So in this case, we want to find out the power supply from this two. This is a source, this is a source. You want to know how much the power in terms of the current and voltage coming out from this two sources, and then how much power actually got absorbed by the resistor of 2 ohm and 2 ohm. So to begin solving this problem, there are many other ways. As I mentioned, there are more than one way to solve this problem, but I am sort of resisted to actually going through this Norton-Davenant equivalent conversion, because I want to retain most of the information shown here. So I think KVL will be a good candidate to begin solving this problem. As you can see from this figure, I put this as the V1 and V2, and these are the two variables that you can begin writing the KVL equation, and that means that consistently for this two node, I'm going to sum all the current going out from that node is going to be 0. And in this case, we have a 4 amperes of sign coming into this node, which is again the sign. So I'm going to write 4 ohms here, minus 4 ohm here, but I usually deal with constant on the other side of the equation. So I move that minus 4 here to this side, 4 amperes, which come from minus 4 to positive 4 amperes. And then the other two term will be V1 minus 0 divided by 2 ohm, which is this term, and then V1 minus V2 divided by minus J2 ohms, which is this term. So that completes the first equation. The second equation will be very similar. So you're going to define going out current from this side, going down, and then going to the 12 volt voltage source. So V2 minus V1 divided by minus J2 plus V2 minus 0, because this is the reference we are dealing with, divided by J2 ohms. And then V2 minus, in this case you already have the constant of voltage source, which is 12 with a 0 degree, so we're just going to write V2 minus 12 divided by 2 ohms here. So here we go, two equation, two unknown. You can easily solve it using your calculator. The only thing that you have to do is to put them in the proper form so that you can plug it into the matrix that to find out the V1 and V2. And to do that, presuming that you plug in the number correctly, organize it correctly, this is a number you get. V1 is equal to 6.45 with a degree of 29.74 degree, and then V2 will be 10.43, 32.47 degree. So here we go. We're done finding these two variables. The next step I would like to do is that once we find out the V1 and V2, you have to sort of find out how much the voltage and the current would be. So in this case, what I am going to do is to find out the voltage for the 2 ohm across this resistor, how much the voltage would be. So to find out the voltage across this 2 ohm resistor will be minus 10.43 plus the 12 ohms together. So you add them up together, and it ends out you have the 6.45 magnitude with the degree of minus 60.26 and volt. So to find out the current going out from this, so you basically have to use that voltage divided by 2 ohms. And then in this case, I am converting this plus minus sign into the positive sign because it's going out this direction instead of the other direction. So that's why that there's a change of sign here from positive to from negative to positive, and the divided by 2 here is basically the 2 ohm of the resistor. So what do we have now so far? As you may recall, I may not talk about this in the class, but from the circuit 1 class, the RMS value will be the Vm, which is the voltage magnitude divided by square root of 2. So this I can't go through all this proof in the sinusoidal waveform, but you go look at the first circuit, you will realize that the square root of 2 is mathematically is actually the sort of averaging on a sinusoidal curve. And presuming this is right, then the voltage supply will be basically V times I in this case, but we have the angle information for voltage and current, so you have to take that into consideration of the difference of angle of voltage and the current. So this is the voltage for the supply for the first one multiplied by 4. This is the one that we found from the first equation, V1 multiplied by 4 ohms, and then this a degree of 29.47 minus 0 degree, and then the half here is actually referring to this equation. So the voltage times the current, the square root of 2 times another square root of 2, that give you half. So that supply for first term will be 11.2. The same thing for the second source, which in this case will be the 12 multiplied by the 3.22 magnitude of the currents. And again, this is coming from a 0 degree. Minus 60.26 is from this current information. So what you can do is that to add them two together, you will get 20.8 watt in this case for the power supply. Again, what we are doing here for the power supply is to add two term out. This is one term, and then this is a second term that I've shown in this equation. So the other question asked is the average power absorbed by each element in the network. So it refers to the two resistor we are talking about here. So to do that, if you recall, I square R is actually the power absorbed dissipated on each element. So what we care about is the following this equation. So this is the I square R, and the half again is actually coming from the root mean square value. So you have square root of 2 multiplied by square root of 2, you get 1/2 of that. And 6.45 is actually divided by 2 because you want to find out the current, and then the square root the square 2 is actually you amplify that, multiply by the 2 ohm. This 2 cancel out. 6.45 divided by 2 will be close to 3.2 something of the square, that give you 10.4 watt. So this sign is actually referring to things going to this direction. What about this one? Same thing. We are going through the same numbering because the current going to down here is actually 6.45 divided by 2 because we have 6 ohm resistor. So going through the same process, 6.4 watt for first term and the second term, it add up to be 20.8 watt, which is they both are equal in this case. So this will end out a very short tutorial for this question. And if you have any other question about other question in the textbook, feel free to email me. Let's stop here.